it does this. So we're gonna have to go back in here and we're gonna set our speeds and feeds. 600 surface footage, feed rate of, or the chip load, I'm sorry. We had 4,000, so we'll leave that at 4. And we're plunging. We are still gonna come down into the jaw because in the center of this, you know, if we have my material, I mean, I still have jaw there, so I still have to worry about that first time. So I will slow that down again as a plunge rate, just put it at 1. And then the retract is already on rapid, so I'm happy with that. All right, so comment in here, I'm gonna say roughing out the U, just the center portion. All right, holder again, I do not need stock. This is a new one, it's gonna show up in this. So this is kind of a magical one. It's called rest material. It's kind of hard to get your head wrapped around, but what it's going to do is it's going to define the stock as whatever, it's going to look and see what's already been machined and know that it doesn't have to machine that again. So it knows the sides were already milled, so now it knows not to machine that. How do we define that? We're going to go in here and all previous operations. I changed this to machine group only. That's when it seems to work for me. These are one of those parameters you have to tinker with to get it to work. So machine group only is the one that will work for this option. And then I leave everything else alone. It's really just going to help us define what's already been milled and what hasn't, so it knows. Because we saw originally when I did that screenshot, it showed the sides and the middle need to get milled out. So now we'll know the sides are done. All right, so now I'll come in here to cut parameters. This is all information specifically for the dynamic mill. So you can set an approach distance, which I don't usually mess with. You can set a step over on here. So what is a safe radial step over that we can mill into safely with a tool we have? 20%. I think in your speeds and feeds chart, I documented something on there. Got your speeds and feeds chart for peripheral milling. I think it'll say like 13 or 15% cutter diameter. I looked it up one day.
15%.
15%. Let's just stick with the numbers I gave you. So 15% allowable radial infeed. Okay? So we're going to go right here and we're going to change 25% step over to 15%. And what that's going to do is it's going to step over, it tells you right there, it's 75 thousandths. So that's how much off our drawing, if it was sideways, it's going to knock 75 off, 75 off, 75 off per loop as it dynamically mills around there. So that's it there. Toolpath radius, if you click on these, it'll light up and it'll show you what it's actually showing. So like here it's showing you the step over between the cuts. And if we click on this one, it's showing you the radiuses on the edges of it. I don't mess with a lot of these things. They're in there and they're set, and if it works, I leave it alone. Same thing with this, I leave that alone. If I come in here, this is the micro lift distance. So this is how much it's going to lift up when it pretend rapids back on its cut. It's going to lift up 10 thousandths. That's all it's going to do. And then it says how much is it going to back feed? Well, I changed this to 200 inches per minute because I want it to feed back as fast as possible. Again, if you have a newer machine, it can go faster, but ours is locked down with that. Then it has stock to leave on the walls, 50 and 50. Well, I don't want to leave 50, that's too much. I'm going to leave 10, just like we did before. So I'm going to leave 10 thousandths here, and stock to leave on floor, we're going to go 0. So we're good there. Depth cuts, do we need to do depth cuts?
No.
We're going for the whole shebang, right? We're going to engage the whole flute length, so we're good. Entry motion, this will only play in, it says helix only. It'll automatically helix into our part if we were coming into internal features. But we're going to start off the part, so it's going to go straight down in a plunge move without a helix. So it'll automatically know that. This is some of the parameters it understands quick. Breakthrough we won't use. Linking parameters, again, we're always going to use. And again, I'm going to turn this off. Absolute, absolute, absolute. And a feed plane of 100. And top of stock 0. And depth, how deep are we going? 770. Minus 0.770. All right. Home reference doesn't matter. Arc filter doesn't matter. Planes, I will just check and verify. All right, see, here it glitches out sometimes. I want it to be G54, 54, and 54. So I'm going to hit 54 and 54 so I know they're all in the same plane. I'm happy with that. and then coolant, I'm going to turn on again. From there, it's it. It should be done. So, right there, it generated the tool path of knocking through that center portion. So what I can do here is I can click on two of these operations with the shift clicker. Alright, so both of them are chosen right now. I can hit this button here which displays the operations on or off. You can see the tool paths disappear. I like to use that one, and I also like to use this one together with it. I click this one as well, and now it'll only display the tool path I've chosen. So if I click here, we only see the tool path there. If I click on the first one, we only see the tool path there. So you can see visually what the heck is going on with less lines on the screen. See that option? So now we can see how it's going to mill that out. So if we want to look at this, we can always go up here and we can do the back plot and see what it's doing by just hitting play here and watching it kind of chew away at that. Now notice it doesn't go inside of there and mess up because it knows that radius is too big to achieve the radius there, so it just won't get there. That's okay. So if we want to look at even farther, we can choose both of these two, selecting them both. And we can go here to the verify option. The verify option is going to pull up, and you're going to see it show up here and give you a full kind of 3D on what's going on. So I can slow the speed down a little bit, and I can hit play, and it mills the ends, and now you'll see how it's moving that material away from the part. And if we look closely here, we can zoom in and we can see, hey, you know, look at those corners. Oh, it left some material. Well, we told it to, right? Leave 10th out. Also, up in here, this holder gets in the way. I can click on Tool Components, and I can get rid of shank. Holder, there we go. And now I can see what the heck's going on. All right, so here, again, you can see it left, oops, on X and Y, it left stock there too, and it left a lot right there. Well, that's because it knew the radius size couldn't handle what it needed to do. So it'll automatically leave that off for you. So, are we happy so far? Mm-hmm. So from there, I'm just going to close this down. This is a whole other window that will open when you do verify. So I'm just going to close that window, and then we're back to where we were. All right, so at this point, we have everything roughed out somewhat, but we have these big sharp corners in there, right? And those are not going to fly. So we need to get rid of those somehow. So what would be an easy way to get rid of them? Just do a simple contour. And we could just contour around there. When it comes in the corner, it'll just get that material out of there, right? Mm-hmm. But quite a bit of meat there, wasn't there? Yeah. How's that end mill going to handle that corner when it comes into that corner with all that depth and all that tool pressure against it? Is it going to like that? No. It's not, right? So what we're going to do here is we're going to copy the pattern that we just created, that dynamic tool path, and we're going to change the tool size. So I'm going to go right here, and I'm going to right click, and I'm going to drag this down, and I'm going to get this option of copy after. So now, and doggone, I always do that. Since I'd selected both of them, it copied everything. I only wanted to choose the second one. So this contour right here, this third one, is junk. So I'm just going to stop it. I'm going to click on just the third one and hit delete. I don't need that one. So I've got 2D toolpath and 2D toolpath. It's going to do the exact same thing as what this one did, unless I change it. So to change it, all I have to do is go into parameters, and I'm going to go in here to tool size right here, and I'm going to select a new tool. So I'm going to select the tool, and this time I want a quarter inch. So a 1/4 inch flat end mill. Okay. I might double click on this and make sure it's got 2 flutes, which it doesn't, so we're going to change that to 2, and finish that. And now I've got a 2 flute end mill here again. Now I'm going to set my speeds and feeds for this one, so same thing. I'm going to go 600, and when I hit tab, it'll automatically calculate my spindle speed. Well, look what it did. Put my spindle speed at what? 9,000. How fast does my machine go?
About 7 maybe.
8,000. But it's scary to run right at the top, so I'm just going to hard data change this. And I'm going to go spindle speed. I want 700 or 7,500 RPM is the fastest I'm going to go, just because I don't like to run right at 8,000. All right, so I got 7,500 here. Feed per tooth. This is a little bit smaller tool. I might just back off my feed per tooth. Maybe I'll make it and it gives me my feed rate. All right, plunge feed. This one here, in theory, is going to do the same thing. It's going to come down, and it's going to potentially start. No, it's not. No, it's not. This tool will not go into the jaw because we've already removed all that material out of there, and it's going to come into the void we've already created. We can crank this one up. So what I would do here is just match this feed rate, 45 and 45, because it's going to cut into air. And rapid retract is on. Other than that, all these other things.
But you gotta change your chip sheet, or your key, the tube.
I already did that.
Yeah.
Why does that matter though?
It's calculating my speeds right here off my feed rate, off the feed per tooth here. So it's taking the feed per tooth of 3 times 7,500 times 2 to get a feed rate of 45. It's automatically doing all that for me.
But
So.
it's still too fast. It's still too fast.
So you
Because
were right
it's at
clicking.
7,000 RPM. It's too fast for the end mill. Because it was like a 700,000, over 700,000 on fruit to cut.
Right?
It will be like maybe like 3,000, 15 a minute.
It'll work. We're still roughing.
So
We're still in a roughing pattern right now. So it'll work. It'll cut that out of there. I guarantee it'll work. We're going to approach the material differently than you've seen done before, so the tools react completely different. In a normal tool, if you came in there at 7,000 RPM and all that feed, yeah, it's going to want to break that tool off because it's too fast for it. When we go to a finish, we might adapt things a little bit, but right now we're still roughing. It'll knock that material out of there without an issue. We could honestly probably go twice as fast, and it'll still do it. So, you'll see. That's what I want to show you, some of this new technology, what you can do with it, how fast it can actually go. All right, so we're good in here. Everything else inside of here, I mean, cut parameters is going to be the same. Step over, the most I want to go is still 15%. Now that's 15% dictated off my new cutter radius. So you can see that this here changed, but it's still 15%. So I'm going to stick with that number. Everything in here is going to be the same. Stock to leave on the walls. I am still going to leave 10 here because I want to just knock out the corner right now. I don't want to finish everything. I just want to knock out that corner. So I'm going to leave it exactly as it is. The one thing I do need to do before I forget is go back here and go to stock. And actually, I can leave that alone too. All previous operations should still work. So it's going to know how to handle this. Yeah, we're good. All right, so really, linking parameters, the same numbers are still going to work. This is a copy of the other one. The plane should be the same. The coolant should already be on. Everything's good. I said okay. And it'll take a second here. Or maybe I regenerate. Regenerate, there we go. All right, so now you can see what it did. Is it came in, and look where it's at. Just in the corners. So if I click back here, this one did all of that. Now this comes back and just hits the corners. So that's all it's going to do is knock out the corners. And really, I did nothing inside of here except for copy it and make it a different tool radius, but it knew to come in, and you can see it's only doing a few swipes at it to knock that radius out of there. But that's definitely more than one. So that could be too much for the tool, and it could pop it and break it. So now it should be roughed out of there safely. So, to finalize on this portion of it here, all I need to do now is do some finish passes to finish this and clean up all my surfaces that I left stock on. So I've roughed it out on the side and inside of here. So as I finish it here, how do you guys want to do it? I got two options. I could finish it all with a quarter-inch diameter tool, or I could finish the outside with a 1/2 inch and finish the whole inside with a quarter.
Finish it with one tool.
Finish it with one tool. So you want to use the quarter across everything.
Mhm.
Okay? So all we're going to do is this then. We're going to go back into here and we're going to create a contour again. And we're going to do a partial chain. And I should be able to click start point here and end here. Start point here and end here. Start point here and end there. So I've got all three of those partial chains. I hit OK. And I go in, the tool. I'm going to click on tool 2. Again, it jacks it up and makes me set my speeds and feeds. So we're going to set this 7,500. And this is for my finish pass only. So maybe I want to slow my feed per tooth down when I finish pass. Maybe I'm going to go, instead of 4,000s or 3,000s, maybe I'll go down to 2,000s chip load, just so I get a nice finish. So I'll leave that there. My plunge rate, I'm just going to match and put it exactly where my feed rate is. Comment in here, finish.
So you didn't have to worry about your surface feet per minute because you're going 7,500.
I just locked it down because it's going to make me go too fast.
Okay.
So 7,500 here still will work. I know you're skeptical, it'll still work. and we're gonna go 30 and 2 and 30, we're good there. So holder doesn't matter. Cut parameters, it's on wear, I'm happy with that. Stock to leave on walls, 0. Depth cuts doesn't matter. Lead in, lead out, it's still where it was, 10, 10, 45, I'm happy with that. Breakthrough doesn't matter. Multi-passes doesn't matter. Tabs doesn't matter. Linking parameters, minus 0.770. Go to the same depth as everything else. This is already turned off because it remembers that I did that previously. And planes, I don't know why it does that. 54, 54, 54. And coolant on, it remembered that. That's it, we're good. We go okay, and now it just created a path, and a path that'll take it to size. So, for a finale here, I'm just gonna go up here and I'm gonna select all operations, so it lights up everything.
You have to move that tool, right?
What's that?
Showed up under 3. That's to be your last one. You have to move that out. Do you see it?
Under the dynamic.
Oh, you're saying the contour flip. Oh yeah, it did show up there. Okay, and that'll happen, that's fine, we can just take it. I think I know where it is now. Right click, down, move, after. There we go. And regenerate. Uh-oh. So, you can manipulate things, but you can easily mess something up. So now this happened, this went in the wrong spot. So now I need to copy this one first. Move this up in front of this one. Oops. Here, copy, remove before. Contour, 2D high speed with the smaller end. No, this is the wrong one. This one needs to go up. We messed it all up. So, right click and move before. Alright. 1/2 inch end mill.
Now you got your dynamic again on the before.
Hold on. Oh yeah. Boy, that's frustrating. Alright. Drag down, move after. Didn't do anything. Click, drag, move after. This is a little cumbersome what it does.
There
Sorry.
you go.
Contour, 2D high, okay, now it's 1/4 inch and then 1/2. That's backwards. So this one needs to be chosen and drag up and move before. Alright. 1/2 inch, 1/4 inch, contour. We got it. Regenerate it all. Now it's all there. Now we're gonna verify it. Watch it.
Select all your toolpaths. The first one was unchecked.
Yeah, it's just gonna do the dynamic.
Stupid thing.
There it is.
Okay, there we go. All selected. Verify, and now we'll watch it. So we'll hit play here. We can watch it mill. It roughs away there. Comes in, then the smaller one roughs out the corners, then it comes back and finishes the whole thing. It happens like lightning. Done. If we look closely here now, we will be able to see that the lines, it's milled right up to the wireframe that we created previously. It's milled right up to the wireframe. It didn't leave any stock, anything left over. So, alright, so now we've seen it. I got through half of what I wanted to get through today, but you guys are going to start playing with it on your own. So you're going to take these same ideas and same concepts into your project. So it's going to be slightly different, but we get an idea here. And potentially we can get on the machines tonight and start doing something. We got a late start and we didn't get as far as I wanted to. So I might have to walk you through the last little bits. If you're ready to cut the actual part, I'll work with you one-on-one on it. So otherwise, same lab as last week. Just get some real tool paths on there that are going to use some of this technology to remove the material quick.
You said this part to do